Let's get started with our weekly handout. The goal of every investigation is to uncover and present the truth. This means that we have to use trusted, industry-proven tools and ensure that our analysis is reliable and objective, and our methodology is based on scientific knowledge and methods. For example, let's take a look at the File Explorer on Windows. And you can see that the file system is made up of directories and files present on the file system. Of course, directories, also known as subfolders, can have folders, subfolders, and in its nature, it's a hierarchical data structure, just like this. So the user is able to navigate down the subfolders and back, create files, and work with existing applications using the files on this system. In File Explorer, we can also take a look at the properties of the file by right-clicking on its name, for example, and choosing this option. So this is a zip file with its properties. You can see that there's all sorts of information available about the file, including the timestamps, when it was created, when it was the last time modified, and when was it accessed on the system. And there's also a set of attributes available on the file, such as whether it's a read-only, hidden system, and so forth. And the question is, could File Explorer be used as a forensic tool? And the answer is primarily no, because the File Explorer is not designed to protect the data on the hard drive. It will update the date and time when the file or directory was accessed by you, the investigator. Just over here, we just saw this. There's accessed date and time present here. If I try to open this file, it will be updated by using this program. This is unacceptable since you want your evidence to be fully preserved and unmodified since the time it was acquired. Another important feature that you would like to have in your digital forensic environment is an ability to uniformly fingerprint files. For example, if I right-click on this file, you can see that in the set of these menu options right here, I have integrated 7-zip, which is an open source archiver utility, integrated into this menu because it cooperates with Windows Explorer as an option when you install it. And it also adds this option to the menu, which allows me to compute cycle redundancy checks, sums, and as well as compute secure hash algorithm of a file. Secure hash algorithm is one of the examples of digital fingerprints. It's a hash function, a cryptological hash function, which goes and processes the information contained in the file, uses a uniform algorithm to compute a unique number. In this case, I'll show you. This is a 20-byte long unique file signature of the file that I'm using here as an example. It has the specific size in bytes, and for its content it computes this value. But this checksum information right now, which is using secure hash algorithm version 1, is not part of the original Windows File Explorer. Once again, this is a feature that was added to my menu by 7-zip when I installed it. When the files are deleted by the user, they're not actually permanently deleted, they're just marked as being no longer used. So typically in File Explorer, unless this is a recycle bin area, which is still available, you cannot see deleted items, deleted files or folders that were previously deleted by the computer user. Those files that were permanently deleted by the computer user, for example from the recycle bin, are still recoverable, and perhaps you would like to be able to restore these files and be able to view them and analyze them. Also, in addition to this, in your trusted forensic environment, you'd like to be able to fingerprint the entire drive. For example, here I have my C drive. So just to draw a picture of it, it might look like this. It's an internal built-in drive on this computer. And perhaps what I would like to do is to somehow take an exact image of this drive and store it in the file. So this would be my forensic image of this drive. What it means that every block of information present on this drive, I would like to copy bit by bit every 0 and 1 present on the original drive sequentially. I'd like to be able to copy and preserve in this forensic image. We call this forensic copy or forensic imaging process. So then, if I have a copy of the original evidence drive, then I'd like to most likely analyze the copy and not the original drive to be able to preserve it as much as possible. However, how do I know that when I'm working on a copy, it's an exact copy of the original evidence? And so to answer this issue, what we do is that when we make a forensic acquisition of the original drive to create its copy, we compute a digital fingerprint of this drive, which is unique and identifies its entire content. Then, before I start analyzing this specific image, I can also, prior to my work, compute forensic fingerprint of the copy. And as long as these two are the same, I know that this is an unmodified and trusted copy of the original evidence. So this is also something that is critical to have in our as a feature in our forensic tools. But then, could you still use File Explorer in some situations? And the answer is yes. It's limited, but when this drive is fully encrypted, if my file is fully encrypted, perhaps the only way for me to see the content of it, the actual allocated content and still in use on this computer, is to just be able to decrypt it and use the original system to view it in a decrypted format. Right? So in this case, you could still use a File Explorer. In other situations, sometimes you can use it to view CDs and DVDs. They really don't store any copies of deleted files. They're typically just a sequence of blocks, which are good or bad blocks, and all the content is present in the area of good blocks of CD or DVD. But once again, the functionality or capacity of Windows Explorer as a forensic tool is very limited.